Good morning, good afternoon, good evening from whatever part of the world you are watching this right this moment. So I'm going to be taking you, my name is Imusha, and I'm going to be taking you on topic statistics. I would say it's divided into different forms. We have the measure of central tendency, measure of central dispersion. At the same time, we also have grouped and ungrouped data. So first of all, this morning I'll be dealing with ungrouped data. When I mean I'll be dealing with ungrouped data, I mean calculating the mean, median, mode of this data. Mean, median, and the mode of data. Also, you could include range. So the first example we are going to be using this morning, example 1. So I would use this example 1, 1, 2, 4, 6, 5, 7, 9 as an example. So to calculate whatever you want to calculate, the first and the most important thing to do is to arrange it in a specific order, that is either ascending order, that is from the smallest to the largest, or descending order, that is from the largest to the smallest. So we are doing ascending order, that is this way. So smallest to largest. So that is going to be 1, 1, 2, 4, 5, 6, 7, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's what we have here. So the first thing we'll be doing, number 1, we'll be calculating the mean of this data. How do we calculate the mean? It is said, the formula is said to be summation x over summation f in group data. But since we are dealing with ungroup data, the summation f is replaced with n. That is the number of values you have, the number of data you have. And that is going to be, summation x is going to be 1 plus 1 plus 2 plus 4 plus 5 plus 6 plus 7 plus 9. I forgot to say initially that an essential tool in this statistics is your scientific calculator, except you have a very, very good brain that thinks without the use of calculator, probably. So 1 plus 1 plus 2 plus 4 plus 5 plus 6 plus 7 plus 9 is equals to 35 over how many data do we have here? 1, 2, 3, 4, 5, 6, 7, 8. 8. So this is 35 over 8. Which is 4.38. It's best to leave your answer in 2 decimal place. So you could cross check over. Let me give you about 2 seconds to cross check from your side what you got. 1 plus 1 plus 2 plus 4 plus 5 plus 6 plus 7 plus 9. So you have 4.38. I believe you should have done that. So the second thing we are finding is our median. Let's not forget the data we are dealing with here is 1, 1, 1, 2, 4, 5, 4, 5, 6, 7, 9. So that's what we are dealing with. So for the median, the number of data is n, and for median is equals to this total number, that's n, divided by 2, which is equals to 9 over 2, which is equals to 4.5. That means it's falling in between the 4th and the 5th number. So that means we are counting from behind 4 and counting from before 4. So this is 1, 2, 3, 4. Sorry about that. The number we are using is 8. Rather, the total number of values is 8, which is equals to 8 over 2, which is equals to 4. So we are counting 4 from here. Please permit me. I know a lot of times when we calculate we make errors, but still the goal is to get the accurate answer. So n over 2 is 8 over 2, which is equals to 4. So 1, 2, 3, 4, 5, 6, 7, 8. So counting from behind, 1, 2, 3, 4, 1, 2, 3, 4, as well from behind. So we happen to have two numbers in the middle, that as the median. So we have 1, 2, 3, put a line, 1, 2, 3, put a line. Then you do the sum of the two, that's 4 plus 5 over 2, which is equals to 9 over 2, which is going to give us 4.5. See, it's like I was in the process of getting the answer for the median. So I got 4.5 the other time, and that's still eventually what I got now. So that's for the median. And for the mode happens to do with the number with the highest frequency. And if we check here, how many times does 1 occur? It occurs 2 times, 2 occurs 1 time, 4 occurs 1 time, 5 occurs 1 time, 6 occurs once, 7 occurs once, 9 occurs once. So if you check the number with the greatest frequency, it happens to be 1. So our mode is 1. And finally, on this example, calculating range. So the range of this set of values is the largest minus the smallest, as I have said earlier. That is 9 minus 1, which is equals to 8. That is how to get the basics of ungrouped data. So let me pick another example. Let me see another example. Let me go with another example shortly. Okay, example 2. Let's take, for example, we have the scores of 10 randomly selected students of an institution in statistics are taken. So we have 65, 46, 73, 48, 56, 74, 53, 37, 25, and 49. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As I said earlier, the first thing we do is to arrange it in ascending or descending order, that is from the smallest to the largest. So from this example, which number is the smallest? We will say is 25, followed by 37, followed by 46, followed by 48, followed by 49, followed by 53, sorry about that, followed by 53, followed by 56, followed by 65, followed by 73, and followed by 74. Finally, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You notice I'll count a lot in this video just to be sure we don't make mistakes, because in statistics it is quite easy to make mistakes because of the number of values you happen to have. So we have 10 here. So the first thing we are calculating, as we always do, is mean, median. We have median also. We have mode. We are calculating mode 2, and we are calculating the range. So we have, for our mean, we have the summation of every value of x over the total number of data, which is equals to 25 plus 37 plus 46 plus 48 plus 49 plus 53 plus 56 plus 65 plus 73 plus 74 over 10. So if you take your calculator and do your calculations, because as I said earlier, your calculator rather should be your best friend when dealing with statistics. So I believe you are calculating also from your end there. You should have 52.6. 52.6. You can do it to be sure again. 25 plus 37 plus 46 plus 48 plus 49 plus 53 plus 56 plus 65 plus 73 plus 74 equals, divided by 10 is equals to 52.6. That's our value for our mean. Permit me to go to the next page where we would calculate our median. So we have 10 values. That is, n for median is n over 2, which is equal to 10 over 2, which is equal to 5. Going back to the previous page, writing out our data, starting from the smallest, we have 25, followed by 37, followed by 46, followed by 48, followed by 49, followed by 56, 53, followed by 56, 53 followed by 56, followed by 74, followed by, this could be very, very tricky. That's why you have to be very, very careful. 49 followed by 53, followed by 56, followed by 65, followed by 73, before we have 74. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly. This is 74. So we count 5, 5. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is our median value. This is our median value. So we have 49 plus 53 over 2. Which equals to 51. That is our median value. Median value. Number 3, we have our mode. Our mode for this, we know mode is the one with the highest frequency, the number with the highest frequency. And here the number with the highest frequency happens to be all of them because they all occur at a frequency of 1. So the mode is everything. That's 25 to 37 to 46 to 48, down, up to 74. That's the mode. All of them occur at one frequency. And to the last but not the least on this example, range, which is equal to this, the largest minus the smallest value, which is 74 minus 25, which is equal to 39, if I am correct. 49, which is equal to 49. That's the range of this value. So that's really a lot, and we have done really a lot on your group data. So now onto the group data, which happens to be the main bulk of work at this moment. Let me use this example. Okay. So working with the data on this table below, the mean median mode of the distribution would be obtained as follows. I said to find the mean median mode of these values. So the table is given as follows: class, boundary, x, f, fx. This is a small f, please note, and we have capital F. So drawing our table, permit me, my hand might not be straight enough, but please permit. So the first class we have is 40 to 44, 45 to 49, 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74. Don't mind the lines, actually, it's about the calculation. So the boundary. So to get the class boundary, what we do is we subtract 0.5 from the lower class boundary, which is this lower class mark. This is it, lower class boundary, and add 0.5 to the upper class boundary. This is the upper class boundary, 44. The lower class boundary is 40. So you subtract 0.5 from 40 and you add 0.5 to 44. So to get the boundary for this, what you have is 39.5 and this will be 44.5. Before we go further to solve the class bound, to get the class boundary, it's important to note down the frequency given to us in the table. That is 258, 12, 7, 4, 2. And the total frequency, if you calculate it, happens to be 40. So for the class boundary, to continue with that, you do the same thing for the lower class boundary here, lower class boundary, and the higher class boundary here. So lower class boundary here is 45. So you subtract 0.5 from it, that is 44.5 to 49. You add it to this piece, 49.5. But you will notice a very funny irony here. Excuse me. The 44.5 that ends, that is the higher class boundary for the first value, on this first row, happens to be the lower class boundary for the next row. What a funny irony. And the upper class boundary for this current row would see, if you do your calculations properly, it will be the lower class boundary for this next one. So this will be 49.5 to 54.5 and 54.5 on and on like that to 59.5, 59.5 to 64.5, 64.5 to 69.5, 69.5 to 74.5. So we have our F, we have our class size, we have our class interval rather, we have our class boundary. So what we want to get is our class mark, that is the mark. And how do we calculate that? You add your lower class boundary with your higher class boundary, these two, you add them together and you divide by 2 and you get your class mark. So let's start with this that we have. So we do 39.5 plus 44.5, you get 42. Then we do the next, 44.5 plus 49.5 divided by 2, you have 47. You're going to notice something very, very funny towards the end of this. 49.5 plus 54.5 divided by 2 is going to give you 52. You are smart enough, you already notice what I am saying, which is that's also 54.5 plus 59.5, which is divided by 2 will be 57. So if you notice, it is increasing at a rate of plus 5, plus 5, plus 5. So 42 plus 5 give us 47, 47 plus 5 give us 52, 52 plus 5 give us 57, and 57 plus 5 will give us 62, 62 plus 5 will give us 67, and 67 plus 5 will give us 72. If you complete the calculations as we were doing earlier, you would actually see with me that actually we are actually adding 5, 5, 5. And that 5 we are adding that we see there is what is known as class size, known as C, small c, because you'll be needing it in this group of calculation. 5, 5, 5, 5, 5. Now we have f, we have x. We need to get fx and we need to get f. What is f? F is cumulative frequency. Frequency. That is the frequency, when you keep adding the frequency above with the current frequency, that's how you get your cumulative frequency. So for this 2 here, there is nothing above it. So the cumulative frequency for this line is going to be 2 plus 0, that is 2. For this line, you're going to have, for this line, you're going to have 7. On this next line, you're going to have 15. That's 7 plus 8, like that. Then for this line, 15 plus 12, which equals to 27. Then 27 plus 7, we have 34. 34 plus 4, we have 38. 38 plus 2, we have 40. For you to be very sure that you know this thing, for you to be rest assured that your answer you got was correct, it will tally with what you had as a sum of your frequency, that is your cumulative frequency. So before we go further, I would love to calculate the value of fx. Fx permits me to calculate the value of fx. Permit my lines as I said earlier. So 40. So for fx, that is the multiplication of f and x will give us fx. That is 42 times 2, which will give 84. 47 times 5, I believe you should be solving right now with me. We give you 235. 52 times 8. For you to know, we are dealing with the small f here, not the capital F. So 57 times 12 would have 684. 62 times 7, we have 434. 67 times 4, we have 268. And 72 times 12 is to give us 144. Adding all these together, that's 144 plus 268 plus 434 plus 684 plus 416 plus 235 plus 84. Would give us 1645. I told you it's very essential you do you cross check twice, so that will help you to be sure of your answer, especially in exam situations where you are working under pressure so as not to get wrong values. So you will not get wrong values. So let's go again. 84 plus 235 plus 416 plus 684 plus 434 plus 268 plus 144. Your answer, you see why I told us to cross check? The answer is 2, 2. I know some of you might have been wondering, that's not what I got, that's not what I got. So the right answer is 2265. 2265. So to the next page, the first thing as you always calculate is mean. So to get your mean, we have summation fx over summation f. Going back to your table, you have a summation fx as 2265 and you have a summation f as 40. So it's going to be 2265 divided by 40, which is going to give you 56.63. 2265 divided by 40 will give you 56.63. So now there are certain formulas we use in group data. Before I continue, we have mean as this. We have a median formula as L1 plus summation F over 2 minus FB over FM times C. So let's define the values in each of them. L1 is the lower class boundary of your median class. F is equals to frequency, total frequency. FB is the cumulative frequency before the median class. Cumulative frequency of the class before the median class. Before I forget, I need to mention that the reason why group data was followed became the new order of the day that we even use right now is because in exam situations where you have about 100 values, it's not suitable enough to use the normal counting method of 1, 2, 3, 4, 5. That's why it was put in tabular form. So cumulative frequency before the median class, and the FM is the frequency of the median class. So, and the C, before I forget, is the class size we calculated the other time, that one that we got as 5. So now going to the example, we have gotten our mean, we have our median. So median also, as we said, we will still do that for mode anyways. L1 plus summation F over 2 minus FB over FM into bracket C, rather C. So our L1 from this example, from the median class. Before we get our median, how do we know, okay, this particular class is the median class? You check your total frequency, which is 40, You divide it by 2 as we did for that on group data. So 40 over 2, that's telling you that it's at the 28th position. At the 28th position. So if you look at the table, you look at where the 20th position will fall, going through the cumulative frequency. So we have 2, we have 7, we have 15. That means it will fall in this class 50 to 54. 50 to 54, this particular class. So the lower class boundary of that particular class happens to be 49.5. So sorry about that. The lower class boundary happens to fall, the median class happens to fall on the class 54 to 59.5. 54 to 59.5. That's where the median class is. 54 to 59.5. Yes, 54 to 59.5. So the last class is there is 54.5, that's the lower class boundary. So 84.5 plus summation F is 40 over 2 minus the cumulative frequency before that class is 15. And the FM, that's the frequency of the median class, is 12. Minus FB, that's the cumulative frequency, which happens to be 15, over the median class, which is 12. That's the frequency of the median class, as seen here. Then with our C, what our C, as we said, is 5. So what you should get here, so this is 54.5. 54.5. So you should have your answer from here as 56.6. 56.6. You can do well to do it with your calculator. Yes, 56.6. So that's our median. And we have to our mode. Mode happens to be the class with the highest frequency. So what's the class with the highest frequency here? The class with the highest frequency, happens to be this class. This particular class. This happens to be our modal class. So the formula for the mode is as follows. Just follow me closely. Mode MO is equals to L1 plus D1 over D1 plus D2 plus C. Multiplied by C. So what is our L1? The lower class boundary of the modal class, which is this class. Lower class boundary happens to be 54.5. So 54.5 plus D1. Now we have to define our values. What does D1 mean? D1 simply means the difference between the frequency of the modal class and the class before it. I'm taking time to explain what these parameters mean because when we start implementing it, you'll not be confused. So D2 is the difference between the frequency of the model class and the class right after it. So from the table, we can say our D1 is 12 minus 8. Our D1 is equals to 12 minus 8, which is equals to 4. And we can say our D2 is 12 minus 7, which is equals to 5. D2 is equals to 12 minus 7, which is equals to 5. So back to our formula, we have M0, MO, that's mode, equals to L1 plus D1 over D1 plus D2. Our C is the class size multiplied by C, which is equals to 54.5 plus 4 over 4 plus 5 into 5, which equals to 54.5 plus, do your calculations, we have 56.7. 56.7 will be the answer for our mode. So on this episode, that's where we'll be we'll be pausing, and on to the next episode we'll be talking on standard deviation, mean deviation, variance, and so many other things. But on this episode, I'd love to stop on this example of calculating both for group and ungroup data, the mean, the median, and the mode. Thank you. Until next time.